Yeah, so let's begin the next topic, that's loops. So as some of you might be knowing already, there are three kinds of loops in C. So one is while loop, do while, and the third one is for loop. So let's quickly look at the syntax. So while loop will look something like this. So while a condition, or we can also call it as expression. So if the expression is true, it will come inside the while loop, and you have a block of statements which will be executed and close the while loop. Okay, that fellow, yeah, beside the blue shirt, white shirt, get out. Yeah, white shirt. Yeah, you only. Okay, so let's look at the flowchart. So it's quite simple. Basically, it's like an if-else condition put in repeat mode. If some condition is true, you execute that. Again, if that condition is true, you execute that, and so on. If the condition is false, you get out of that block. That's it, right? So here, this is like if-else condition. If this condition is true, you execute the statements inside the loop body. Again, go back and check for the condition. If it is true again execute the statements, again go back and check, and so on. The moment the condition is false, get out of the loop and execute the next statement. Okay, right. So let's look at the next one, that is do while. So do while looks something like this. So first you have the do statement, and then you open the brackets, and then you execute block of statements. And while comes later, while some condition or expression is true. Here there is a semicolon. Here in this while syntax, there is no semicolon either after these brackets or after these brackets. Okay, there is no semicolon at all. Only for each statement in the block there will be a semicolon in general. For do while, after this while statement, there will be a semicolon. Okay, for the entire block. So just by looking at this syntax, can you tell what is the difference between the two? Yeah. Yes. Sorry. Entry control and exit control. Yeah. So this is basically called a pre-test loop. That is, the condition is tested before you enter the loop. This is called a post-test loop. The condition is tested for after you enter the loop. So how does it matter? Exactly. Do while will run at least once, independent of the truth value of the condition. So whether the condition is true or false, this block of statements will be executed at least once. So we will see a scenario where that may be useful. Okay. So let's quickly look at the flowchart of this as well. Yeah, anyway. So like you see here, first you execute the body of the loop, whatever statements are there in the body of the loop, and then you test for the condition. If the condition is true, then you go back and execute the statements in the body of the loop. And again, you check for condition and so on. If the condition is false, you just come out of the loop. Okay, quite simple. The only difference is here, condition comes before the body of the loop. Here, body of the loop comes before the condition. So the moment you start, it is executed at least once. And then the condition is checked for. Okay, and then it is like any normal loop. Fine. All right. Then finally, we have for loop. So in the for loop also you have condition and then block of statements. So in this condition, there are three parts. All right. So the first part is initialization. The second part is test expression. And the third part is update expression. Now, one common mistake which anyone tends to make is one thinks that, okay, this is the order in which the statements are executed. First, initialization, then test expression, then update expression, and then this block of statements are executed. But that is not the case. This syntax is slightly confusing, but the order is first initialization is done, then test expression is tested. If that is true, it comes inside the block and executes this block of statements. And then it goes to the update expression and updates this expression. Okay, so this is the order 1, 2, and then 3, 4. Once this is done, again it tests for the expression. If the expression is true, again it comes inside the block. Again it updates this expression. Again it tests for the expression and so on. Okay, so this is the cycle. This is the direction of the cycle. Normal, usually any student thinks that this is the cycle. Okay, first this is done, then test expression, then update expression, and then this block is executed. And then this test expression is again tested, but that's not the case. Okay, so remember this sequence. This is the correct sequence. All right, so this initialization step is done only once. Once it is done, that's it. You will not touch it again. Only these steps are repeated. Fine. So let's look at the flowchart for this as well. Yeah, so first you have initialization expression and then the test expression, and then you enter the body of the loop, and then you check for the update expression, and then you come back and test the expression, test expression again, and then if it is true, you enter the loop body and then update the expression and so on. Okay, so this is the cycle. Initialization will be done only once. You will not touch it again. Okay, simple. Fine. So now let's look at a few examples for you to understand each of these loops. But before we look at the examples, one thing which you need to keep in mind is all these loops are basically equally powerful. It is not like one loop can do some things which other loops cannot do. All of them can do what each of the other loops can do. The only difference is in convenience. Some loops are more convenient to do or to solve some kind of problems. Some other loops are convenient to sort of handle some other kind of problems. We will look at examples now. Usually when you know the number of iterations, the number of times you need to iterate, you need for loop. If you don't know the number of times you need to iterate, you need while or do while. Any real life examples for loops you can think of? Sorry? Checking prime number. Yeah, but that's not a real life example. In real life, you have many examples of using loops. Your playlist in Spotify or YouTube playlist, or if you want to watch a video in loop, that's a loop, right? Or if you have a sequence of videos, you want to go from one video to the next, you say, okay, I have 10 videos, play one after another. That's a loop, right? Or anything, train ticket reservation, that's a loop. Okay, first this person, then next person, then next person, whoever is in queue, execute or perform the transaction. That's a loop. So you have umpteen instances of loops around you, right? So you can use any of these constructs, for loop, while loop, do while, to do that. All right? Or ATM machine, that's a loop. One person, then next person, then next person. It's waiting for your input. And within each transaction, there are sub steps. First this, then this, then this. Right? If this does not work, then go back and try it again. If that does not work, then go back and try it again. It goes in a loop. Maybe that loop has a limit, or that loop may not have a limit, right? So all these are examples of loops. Okay. So let's take a simple example. So every cycle is called an iteration. In each iteration, all the statements in the block are executed. Again, it goes back to the starting and executes the block of statements again. So each one is called an iteration. So if you want to do n times, those are called n iterations. Fine. All right. Now let's look at an example. Suppose I want to write a program which takes an input character and prints its ASCII value and repeats this process until, so there are multiple ways of specifying the terminating condition. One way is you just pre-decide how many times you want to do it. Maybe I want to do it 10 times or 100 times or something like that. Like say ATM machine may give you 3 attempts to check your PIN. If that is wrong, it will not allow you. Or changing a password. Again, that's a loop. You are given 3 attempts to change your password. After that, your account is blocked. Maybe if it's a bank account or something like that, right? So there is a limit on number of times you are allowed to change your password. So that is one way where the number is fixed. 10 times or 100 times, I want the program to allow me to check for a character's ASCII value. Or another way is there is no limit. As many times as I give it a character, it should tell me what is its ASCII value, and I will tell it when to stop. So one way of telling it when to stop is I give a special character. The moment this character is given, it will understand, okay, now the user wants me to stop, I will stop. So here the number is not fixed. It can be 10, it can be 100, it can be million also. It will keep doing whatever you ask it to do until you give the special character. Okay, so for now, we will sort of treat, we want the program to quit when we give, say, the character Q. So Q we are treating as a special character. So we are not worried about the ASCII value of Q. We are worried about the ASCII values of all the other characters. So when I give Q, it should just quit. But until I give Q, no matter how many times I ask for it, 100 million, billion times, it should keep giving the ASCII value of that character. Okay, so until Q is entered. So first, let's look at the pseudocode. A very simple, basic pseudocode without any concept of loop, without for loop, while loop, whatever. In the common sense, for a common, for a person with common sense, this is how they would think of the steps. First, I will read a character. Then what will I do? Yeah. If the character is not Q, then print its ASCII value. This is pseudocode, so it is not specific to any programming language. You're just sort of writing it in natural language. Print its ASCII value. And then what is step 3? So let me put it here. Okay. Yeah. What is step 3? Yeah. Exactly. So step 3 is you go to step 1. So this is the concept of a loop. You have different steps. One of these steps points to one of the previous steps. That's it. That's how a loop is created. Now you can convert this process into for loop, while loop, do while, whatever it is. But the concept is independent of the syntax, right? It is just repetition. Like I said, any loop is nothing but an if else condition put in repeat mode. That's what is happening here. Okay. So now let's look at the pseudocode in terms of while loop. So again, the first step is read the character. Now, while the character is not Q, okay, what do? Print ASCII value of CH. That's it. Will this work? Yeah. Scanf. So where should I write? We already did. No, this is scanf. So done. This code will work. Okay. Suppose let's say read should be within the while loop. Okay. So if read is within the while loop, then where will I get the value of CH without reading anything before while loop? Okay, we can use do while. We will look at that. But before that, with while also we can do. How to do? 2 scanfs. So I put one more read here. So will this work? Which read? Exactly. So this read should be below this printf. Okay. So first you read a character. Now, if that character is not Q, you print its ASCII value. And then read the next character. And now it will check whether that character is Q or not. If it is not Q, it will come inside and print its ASCII value. Now you read one more character. It will read the character, then check if it is Q or not. If it is true, if it is not Q, then it will print its ASCII value and so on. So the first read is happening only once. Before while loop, you are reading a character just to start the process. Once you enter while loop, you are printing and reading. So here what is happening is the ASCII value of the character which you are printing the ASCII value of the character which you read in the previous iteration. the character which you read in the previous iteration, you are printing its ASCII value in the current iteration, not the same iteration. That's the difference. It's slightly confusing. So, but it does the same job, which can be done using do while also. We will get there, but it does the entire job. Okay. Only thing is you need to slightly wrap your mind around it to understand what is happening. So this is called dry run. Okay. When you actually run your code in the machine, that's normal execution running. But you can also run your code in your mind or on paper. That is called dry run. In fact, you should make a habit of dry running your code rather than every time running it madly on your computer and then checking if it is working or not. Okay, make one more modification. Is it working or not? So don't do it madly. Just try to run it in your mind first. That's what we all did just now, so that we got the right code. Okay, so make it a habit. So first let's execute it and then see what will it give. First, I declare a character and then I read it. And then I start a while loop, while ch not equal to q. Print. So how do I print the ASCII value of a character? %d. So like I said many times, whatever data you're giving, it is a number. That's it. The format specifiers are only the representations of this data. So if you want to take an input as a character, give %c. If you want to take the input as a number, give %d. Similarly, if you want to print the data as a character, give %c. If you want to print the data as a number, give %d. That's it. So I can take an input as a character and I can print it as a number. So I can use scanf %c and I can use printf %d. That's it. And then one more scanf. I need to read the next character, right? In the loop. Or before that, suppose I don't print that. Okay. Let me put it and comment it. I don't scan. I'll print, but I won't scan. Any guesses what will happen? Infinite. It will go into infinite loop. But what will it do in that infinite loop? Yes, whatever character it read first, it will print its ASCII value infinitely. Okay, so let's see that. Any character I give, suppose I give G. You see, it's printing. It's actually printing infinitely. It's difficult for you to see. It's going on. Okay, so whatever you do, it is printing. So you have to stop it. That's the only way. So to force stop in Linux, in any terminal, you press Ctrl+C. Stops it. Okay. So these are the kind of issues, particularly in loops. This is one main issue which you may get into, because if your terminating condition is not clear, it will just run into an infinite loop. Okay. Sometimes you may not even know that it is running in an infinite loop. In this case, we know because we are printing. Suppose if I'm not printing, I'm doing something else, and the terminating condition is never reached, it will keep waiting or it will keep doing something and you will not even know that. Okay, so this is something for you to keep in mind. So now it prints a character and then it immediately waits for the next character, and then it prints a character, waits for the next character, it prints the ASCII value, waits for the next character, and so on. Okay. Okay, now I'll come to this why two values are being printed, but let's you notice, do you understand why two values are being printed? Why? Huh? Exactly. It is taking the enter button also as a character and printing the ASCII value of the character as well as enter button. That's why you are seeing 10 every time, because I'm pressing enter every time. I pressed enter. That's why it's going to the next line. But the key enter itself is a character. So it's reading G as well as backslash N. And it's printing the value of G and also backslash N. Okay?
So what if we don't click enter? Will it print?
It will not print. If you don't click enter, it will not print. Like I pressed J. It's not printing. It is.
What do we do without enter?
I'm coming to that. Huh? Minus 10. What do you mean minus 10? For what? No, I didn't get. In the printer statement, what should we do? Okay. How does it matter? It will still print 0. It will print 2 lines, 2 ASCII values. It will not stop it from printing the ASCII value of enter. Okay. In fact, it will take as many characters as you give, and it will print all their ASCII values and ASCII value of enter at the end. Okay. So it is waiting for you to enter something to finish scanning. Until then, it won't output anything on the screen. All right. Fine. This is all fine, but I don't want enter to be printed. I want it to skip. Now, even if I give space, that also it will take as a character. Yeah, we will come to that. So suppose I say A space, B space, C, or B space C. What will it print? A's ASCII value is 97. Space is 32. So it will print 97, 32, 98, 32, 32, 99, and when I press enter, 10. Okay. So that's what it printed. Exactly what we thought. 97, 32, 98, 32, 32, 99, 10. Fine. Now I don't want any non-white space character to be read or its ASCII value to be printed. Fine. So let's try that. So right now, how do I quit? It's not an infinite loop. It's a normal program. So Q. I gave a terminating condition. Fine. All right. Now, so let me copy this. So what we will do you remember I told you how to skip white space characters in scanf? Huh? Space before percentile C. Okay. What will happen if I give space after percentile C? It will expect. Yes, it will skip all the white space characters and it will wait for a non-white space character to finish scanning. So first let's do this and then I'll give you the right answer. Okay. Suppose I give G. It's not doing anything. It is not printing enter ASCII value also. It is not printing space ASCII value also. I can give any number of white space characters. It is actually skipping them. Now, suppose if I give A, what do you think will it print? If I press enter now, ASCII value of G. If I give some other, say C, what? And if I press enter, what will it print? ASCII value of A, 97. Okay. So what is happening? It is scanning G and then it is waiting for all white space characters to be finished. And the moment you enter another non-white space character, this scanning will be done. Okay. So the previous non-white space character, its ASCII value is being printed now. The current non-white space character, it read, but then it is again waiting for all white space characters and the first non-white space character. Until then, it will not print. Okay. So again, so if I give maybe I, it will print the ASCII value of C. Okay. If I give Q, will it print ASCII value of I or not? How many of you think it will print ASCII value of I and then stop? How many of you think it won't print anything and quits immediately? It will print ASCII value of I and then stop. It will not stop immediately because it is waiting for the next non-white space character. Okay, stop. Fine. Now we took the value of Q. All right. So to avoid this, simple method is put the space before percentile C. You see, if you have two or more format specifiers, giving space in between doesn't matter. But if you give space at the end of a format specifier, then you will run into these kind of problems. So if at all you want to skip white spaces or anything, always put it before, and you have only one format specifier. Give it before the format specifier rather than after. Okay, now, and another thing, this will work exactly whether you give white space or even new line or tab. It's not like new line is not like a comma where it will read one comma and then go to the next thing. No, new line also stands for unlimited white space characters. White space also stands for unlimited white space characters, but a comma or semicolon stands for one comma or semicolon. Okay, so these are different. All right. So before I show you this, so let me show you with the new line also. Same thing will happen. You may think, okay, new line means it will, once you enter one new line, then it will read the next character. No, it will not read the next character. It will try to skip all the white space characters. It's the same code anyway. Again, you see, same thing. So it's working exactly in the same way, whether it's white space or new line or tab, whatever it is, all of them indicate skip all white space characters. That's what it means. So don't give it at the end. Give it in the beginning. All right, now let's see how it works. Suppose I give K, it prints the value of K, and then it skips all the white space characters. If I give A, it immediately prints 97, and then you give any number of white space characters, it will not print them. If I give I, it prints. If I give Q, stops. Okay, fine. This is what we wanted. That's it. All right. Now, fine. I'm getting the ASCII value of every character except Q. Suppose I want Q to perform both the roles. I also want Q's ASCII value and then to quit. Then what to do? Just use do while. Same code, just use do while. So always make it a habit to write the pseudocode first. You need not write entire code on paper with syntax, everything. Just write the logic and then translate it into program. Okay, so that it's easy for your mind to translate your algorithm into code. All right. So So do while. So should I read the character first before do? Suppose I say read character and then I say do. What should I write? Print its ASCII value. And then again read while ch is not equal to q. Is this correct? Yes. No, that's the idea, right? That is not the problem. The problem is something else.
Only if the initial value is Q.
No. Read ch before. We can write this inside the loop. And then what about the second read ch? So there will be two read chs.
We don't need to write two read chs. Only one is enough before printing. Read ch, then if ch is not equal to q, we can print, else we can break off.
Okay, that is one way, but that is making it too complicated. I mean, that is one way. Yes, if ch is not equal to q, then print, else break. Too many if else conditions. Simpler thing. Okay, so there is a similar code that so in this while thing, this is okay. This is for handling new lines. Like earlier in the first version, when I typed G and then printed new line, it printed G's value and then also new line. So one way to avoid it is if the character is not new line, only then print its ASCII value. So here scanf %C is not changing. You are not adding space before %C or after %C. You are scanning every character as you are getting. You are saying if it is not new line, then print. But then what about space? What about tab? You need to add more conditions. If it is not space or not new line or tab, only then print its ASCII value. Then so many if else conditions you need to add. But the simpler version is like what I showed. Put a space before %C, it will skip all the white space characters. Okay, so that is one thing. All right. So now simple way to do it is just remove this, put this here and put it here. That's it. So what is happening? It is reading a character, printing its ASCII value, and then it is checking whether it is Q or not. If it is Q, it will quit immediately. By then it had printed its ASCII value. So in the previous case, it is first checking if it is Q or not and then printing its ASCII value. In this case, it is first printing the ASCII value and then checking if it is Q or not. That is the difference. So now both the purposes are served. It is printing the value of Q and also it is quitting on Q. And another thing is here, it is printing the value of the character which it read in the same iteration. So it is more intuitive. You are reading something, printing its value, reading something, printing its value in the same iteration. Whereas in the previous case, you are printing the value of a character which you read in the previous iteration. You read some character in second iteration, you are printing its value in the third iteration. In third iteration, you are reading a value, you are printing its value, you are reading a character, you are printing its value in fourth iteration. So it is one iteration late. Whereas here, it is in the same iteration. It is more natural. You are able to do everything in while also, but for this problem, do while is more natural. Okay, so that's the idea. For each problem, a particular loop construct will look more natural. All right, it is more simple. You don't need to read something before the loop, again read something inside the loop, two read statements. No, single read statement, single print statement, and also it is serving both the purposes. It is reading and printing. Even on queue, it is printing its ASCII value and quitting. It's doing everything we want. Okay, so that's the difference. So let's quickly do it. Now do, actually here it will come inside and then print the ASCII value of this character while this character is not equal to Q, semicolon. Okay. Now you put a space before %C to ensure that all white space characters are skipped. Okay. Anything you give white space characters are all skipped. I give Q, it prints its ASCII value and then stops. Okay, that's it. All right. Now, same thing can be done using for loop also, but we will look at this example after working out a slightly simpler example for loop. I will need to take 5 more minutes because the class started late. Okay. So let's look at another example which is more convenient for loop. Something quite simple. Print numbers from 1 to 100. As simple as that. It's just a, or 1 to 10,000. Okay. Here you know the number of iterations. For these kind of things, for loop is better. So before we even look at for loop, let's look at the simple pseudocode. First, you initiate some variable to the first value that you want to print, I equal to 1. Okay, this I is also called iterated. That's why you usually use I. And what will be the second step? If I less than or equal to 10,000, print I. Okay. And then third step, increment I by 1. Increment I by 1. You can, in some other examples, you can increment I by 2 or 3 or 5, whatever you want. In this case, we want to print every number from 1 to 10,000. So increment I by 1. Okay. And for this, you can use anything, I plus plus or plus plus I or I equal to I plus 1 or I plus equal to 1. Yeah. Hello. What? Event. I plus equal to 1 or I plus, any of these methods you can use, but be careful with I plus plus or plus plus I, depending on, in this particular case where we place it, it doesn't matter. I mean, in this particular case, because the place where we place it is independent, it will work. But if it is part of a larger expression, you need to be careful. Okay, we will see that. And then finally, what is the fourth step? Go to which step? Step 2. What if we go to step 1? Again, I will become 1 and then it will print 1. It will increment it to 2, but then it will again become 1. So what will happen? What will it print? No, it will print only 1. And how many times? Infinite times, because it will never reach the terminating condition. What is the terminating condition? When it reaches 10,000. It will never reach 10,000, so it will never stop. It will keep printing 1 infinitely. Okay, so the same thing we sort of convert to for loop. The pseudocode is quite simple. For I going from 1 to 10,000, print I. That's it. It's quite simple pseudocode, but we will see how it is translated to code. Let me copy. reduce typing time. So there are different ways. So first you can say int I, and then you can say for I equal to 1, I less than or equal to 10,000, I plus plus, print the value of I. Okay, you can concise it further because there is only one line. You can remove the brackets and put this printf statement in the same line. Like I said multiple times, if your block of code has only one statement, you don't need to put the brackets. If your block of code has more than one statement, you need to put the brackets. Okay. Printed all 10,000. Okay. Yeah. All right. Now, okay. What about the previous example, while loop? So there is a straightforward equation between while and for loop. So if we take this example, this for I equal to 1, and another thing, these are separated by semicolons, not commas. Don't make that mistake. It's important. All the three conditions in for loop are separated using semicolons, 2 semicolons. I less than or equal to 10,000, I plus plus, print I. If I have to convert it to while loop, how do I do that? First, I equal to 1 or int I equal to 1. And then while I less than or equal to 10,000, print I, and then I plus plus, and then close the loop. Okay. So you see the sequence. So this initialization statement comes before the while loop. And then this condition, the middle condition, test expression will come inside the while condition. And then whatever block of statements you have here, they will come here. In this case, there is only one statement. So one statement is here. But if there are more statements, you will have more statements here. Finally, this update expression will come at the end. Okay. So this is the sequence. Now, so I won't type it. It is easy. That's fine. Similarly, you can convert while loop to for loop. So if I take this, so if I, okay, not do while. So here, what we need to do, this scanf, I will convert to a, I mean, this while loop, I'll convert to a for loop. Or here, the initial condition is this scanf. Okay, I scan this, and then this condition will go as the second condition. CH not equal to Q. CH not equal to Q. And then this last statement will go as the update expression here. All right. And then the inner block statements will go inside the for loop. Okay. So whatever you did earlier, same thing will work here. So let's check this. Done. It's working. So one can be translated to the other easily. Fine. Another thing is this last thing can be even empty also. I mean, you will understand those differences later. Okay, it will work in the same way. So right now, use all the three things, three components. You will understand what to keep, what not to keep, how to play with it. That's just your creativity. Okay, but otherwise, that's how it works. Fine. All right. So let's stop here.